And now a topic that has stumped a load of students for years and years and years, and it's also discriminant and also quadratic inequalities like we've got here. This is an inequality because you've got the less than sign, but you've also got a quadratic, you've got something squared. So what we need to do for this one is we are told that this and this don't meet. So therefore, if we set them equal to each other, 2px squared minus 6px plus 4p equals 3x minus 7, there's going to be no solutions to that. So if there's no solutions, as soon as you start using the word no solutions, or the term no solutions, that sort of evokes images of the discriminant. So if we get everything onto one side, minus 6px minus 3x plus 4p and then plus 7 equals 0, then we're saying that this has got no real solutions. So if we get it so that we can have x squared, x's, and then numbers, so write it as 2px squared plus, in brackets, minus 6p minus 3, lots of x, plus in brackets 4p plus 7. If we say that this has got no real solutions, then we know that b squared minus 4ac is going to be less than 0. And now, by doing that, we've got ourselves an inequality. So it's just a case of doing the b squared minus 4ac. So b is always a thing in front of the x. So b squared is going to be minus 6p minus 3 squared, so minus 6p minus 3, minus, and then 4ac I always stick in brackets. So 4 times a, which is 2p, that's the thing in front of the x squared, times by c, which is 4p plus 7, and all of that is less than 0. So let's simplify that. Minus 6p times minus 6p is going to be 36p squared. Minus 3 times minus 3 is going to be plus 9. Plus 18p, plus 18p, and then you've got 4 times 2p, which is 8p. 8p times by 4p is going to be 32p squared. Then that's going to times it by a minus because there's a minus outside. It's going to be minus 32p squared. Again, doing the same thing again. 4 times 2p is 8p. Times that by the 7. 8p times 7 is 56p. Then you times it by this minus, which is outside the brackets, so minus 56p is less than 7. So then 36p squared, take away 32p squared, is going to be 4p squared, which is what we've got here. 18p plus 18p is 36p. Take away 56p. So 36 take away 56 is going to be minus 20p. Then you've got plus 9 and nothing else there, so plus 9, and that's going to be less than 0. And that's how you end up with that quadratic inequality, which isn't straightforward. So now we've got to find the hence, so we use this, find the possible set of values for p. So we've got to solve this quadratic inequality. Now, whenever you've got a quadratic inequality, and I'll repeat this in every time this question comes up, we always do a graph. So we know that this graph here is going to go through at 9. And the way we find out where this graph goes to the x-axis, or in this case the p-axis, is we're going to factorize it if we can. If not, solve it using the formula. So 4p, 9 and 1 don't work, but if we do 2p minus 9, 2p minus 1, that would work. So 2p minus 1, that goes, so if we set that bracket equal to 0, 2p minus 1 equals 0. 2p equals 1, so p equals 1/2, so it goes through at 1/2. 2p minus 9, so we set this bracket equal to 0, so 2p minus 9 equals 0. 2p equals 9, p equals 9 over 2. So 9 over 2. If we sketch it, we know it's going to be, because it's a positive p squared, it's going to look like a positive parabola. So let's do that. It goes through there. And it's going to go up like that. Now what we've got to do is we've got to find out where that is less than 0. So there's only one bit of the graph which is less than 0, which is this bit here. If it says greater than 0, we have two separate bits of the graph, so we need to have two separate inequalities. That's not the case in this question because it's less than 0. So there's only one bit of the graph, so there's only going to be one inequality. And that is where p is less than 9 over 2 and greater than 1/2. So that's it. p is in between or less than 9 over 2 but greater than 1/2. And that's what it was on the 2016 paper. Again, not a question that was done particularly well. Okay, so let's have a look at the self-same thing. We've got this where it has no real roots. So as soon as it's got no real roots, we're going to write down that b squared minus 4ac is going to be less than 0. But this time they've already got it rearranged for us. So b is going to be 4, so it's going to be 4 squared minus, and then 4ac we stick in brackets. So 4 times by a, which is p minus 1, times by c, which is p minus 5, is less than 0. So that's going to be 16 minus, let's keep this as is for the time being. So p minus 1, p minus 5, we expand these brackets here. It's going to be p squared plus 5 minus p minus 5p is less than 0. Okay, so 4 times p squared, and then there's a minus there, so minus 4 times p squared is going to be minus 4p squared. And then we've got a minus 4 times 5 is going to be minus 20. And then we've got minus p, take away 5p, so that's going to be minus 6p. So minus 4 times minus 6p is going to be plus 24p, and that is greater than 0. So if we tidy this up, we've got minus 4p squared plus 24p minus 4 is less than 0. Now what we can do now is times everything by minus 1, so we change the sign of everything. But if we do that, to get 4p squared minus 6p plus 4. If we change the sign of everything, we've got to change this to be the other way around. But that still doesn't look like this. So what we're going to do is divide through by 4. So that's going to be p squared. So I've already tried to divide by 4 there. That should be 24p, sorry. So if you divide through by 4, that's going to be 4p squared. So p squared minus 6p plus 1 is greater than 0, which is what we've got here. And then we've got to find the possible set of values for p. So again, we've got to solve this quadratic inequality. It's an inequality and it's got a p squared, so it's going to be quadratic. So we've got to somehow solve that. And the way we do that is we draw the diagram. So we know that this goes through at 1. And now we need to see where it goes through the x-axis. But we see soon enough that we can't factorize this. So we can solve it using either the quadratic formula or by completing the square. Now completing the square is a good thing to revise. So if we do complete the square with this, p minus 3 squared, so whatever this is, we halve it. And we take away 9 plus 1. We're going to set that equal to 0. So p minus 3 squared minus 8 equals 0. P minus 3 squared equals 8. You square root both sides. So p minus 3 equals the square root of 8, which we should know is the square root of 4, square root of 2. Square root of 4 being 2. So that equals 2 root 2. But remember, when you square root, you're going to have a plus and a minus. So we've got p equals 3 plus and minus 2 root 2. So if we've got p equals 3 plus 2 root 2, this here is going to be 3 plus 2 root 2. Now 2 root 2 is actually less than 3. So 3 minus 2 root 2 will still be a positive number. And then we draw a graph in. It looks like that. And what this question does, the opposite to the last time, we want to see where this graph is greater than 0. So where it's greater than 0 is going to be this bit here and this bit here. Because right there and there, your graph is above the 0 line, so therefore it's greater than 0. So because there's two separate bits of the graph, you're going to have two separate equations. So the values of p are when p is greater than 3 plus 2 root 2, when p is less than 3 minus 2 root 2. And that's how you do the 2015 version of that question. Now, the 2014 version was a little bit simple, or a little bit simpler. So the first 2 marks, we're going to add x to both sides. We're going to add 7. So we've got 4x is greater than 10. X is greater than 2.5, or 10 over 4, or 5 over 2. This one here, again, it's a quadratic inequality. So we get it onto one side. X squared minus 9x minus 36 is less than or equal to 0. So then we sketch this. So we know that that is going to go through at minus 36. We factorize that. Set it equal to 0. That's going to be 12 and 3. That's going to be minus 12 and plus 3. So the two values are x equals 12. X equals minus 3. So therefore it goes through at minus 3 and it goes through at 12. And then sketching that, it looks like that there. And we've got to see where this is less than or equal to 0. So where it's below the x-axis, this bit here. So therefore, what we've got is when, for this one, x is less than or equal to, because remember, it can be equal to as well, 12, but greater than or equal to minus 3. And then finally, we've got to solve both of them. So we need to know when x is greater than 2.5, when x is between minus 3 and 12. So therefore, x is going to be less than or equal to 12, but it's going to be bigger than 2.5. And that's how you do the questions for that topic.